Hello everybody. This is going to be a quick video to discuss the reaction rates of heterogeneous systems. So heterogeneous reactions are those that occur between reactants with different phases. So something that's, say, a liquid and a gas reacting, or a solid and a liquid reacting. The reactants have different phases. And an important aspect whenever you're thinking about reaction rates is that the step that's going to determine the overall reaction rate is always going to be the slowest step. Okay, if another step is faster, then it's always going to be waiting for the slowest steps, and the slowest step in a heterogeneous reaction is what's going to occur at the is going to be the rate at which the reactants can interact at the interface where the two phases meet. So it kind of makes sense that if you had, say, like a solid that's reacting with the liquid, it's only going to react on the outside surface of the solid, and the inside of that solid isn't going to be reacting, and that's going to be the slowest step. So we can increase the reaction rate when the surface area between the reactants is maximized. So if I can expose more of the solid to the liquid, or if I can expose more of the gas to a liquid, then I'm going to be able to increase the reaction rate. The surface to volume ratio, which is what we're really talking about here, because we're going to have a fixed volume that we're going to be reacting, and we want to give it the highest surface area. So we want to increase the surface to volume ratio. This can be increased by grinding solids up, right? Exposing more of the inside of the solid to the other phase that we're trying to react it with. We can do this by mixing liquids. So if we had even two liquids that weren't going to mix together, that are reacting together, we can mix them together and disperse droplets of one in another. And aerating gases. So you might see something like this in, say, like a aquarium, right? You have a little bubbler and it wants to add oxygen into the water, and if we aerate it by making tiny bubbles that come up as opposed to just one big large bubble, then we'll increase the surface area that's available for it to absorb into the water. So you see a lot of elaborate little stones and stuff that kind of just make little tiny bubbles that travel up, as opposed to just one tube that's having these big old blump blump bubbles that come up.